Hello, pre-calc students. Doing vector word problems. So, Lucas programs his quadcopter to fly with a velocity, speed, and direction, vector p of 4i and 7j, which is send it straight at its target in the absence of wind. To his dismay, the quadcopter actually moves with a velocity of 2i plus 8j. So, what happened is that you had a horizontal component, vector p, had a horizontal component of 4 and a vertical component of 7. So this is vector p. We have a horizontal component of 4 and a vertical component of 7. All right, to his dismay, the quadcopter actually moved with a velocity of a, which had a horizontal component of 2 and a vertical component of 8. So what Lucas did not account for was vector W, which is the wind. And so we need to find out what's the component form of the wind. All right? Well, if the quadcopter flew with a horizontal component of 4 without the wind, and then with the wind had a horizontal component of 2, the wind must have a horizontal component of -2, because only -2 could you add it to 4 to get +2. And the wind also must have a vertical component of 1, because 7 plus what equals 8? 7 plus 1 equals 8. So the wind has a horizontal component of -2 and a vertical component of 1. All right. That being said, we now need to find the magnitude and the direction of the wind. So remember, our wind has a horizontal component of -2 and a vertical component of 1. So, let's draw an xy axis. We have a horizontal component of -2, a vertical component of -1, okay? And then this is our vector W. Or vector, yeah, so that's vector W. So let's find the magnitude, all right? The magnitude, if this has a value of -2, this has a value of 1, it's just the hypotenuse of the right triangle. So to find the speed of the wind, we know that that speed, we can call that speed the magnitude of vector W, is going to be equal to the square root. This is the Pythagorean theorem right here, of -2 squared plus 1 squared. So that's going to be equal to the square root of -2 squared is 4, and 1 squared is 1. So that's going to be equal to the square root of 5. And now it says to round our answer to the nearest tenth. So to find the square root of 5 to the nearest tenth, I can take my trusty old calculator and find the square root of 5. That's going to give me 2.23. So if I ran into the nearest tenth, that would be 2.2. All right. What is the direction the wind is blowing? Now to theta, our angle, is right here. And theta, to find theta, that's going to be equal to the inverse tangent of the opposite 1 over the adjacent, which is going to be -2. Let's find the inverse tangent of, oh, and sorry, I drew this wrong. if our 1 is positive, right, -2, +1, and we draw our vector as such. So find theta, right, the inverse tangent of our opposite 1 over adjacent -2. So I find, with my calculator, the inverse tangent in degree mode I take the inverse tangent of 1 divided by -2. And that's going to be -26.5. That's what the calculator output. What that's really saying is that this angle right here is 26.5. So to find our actual degree, which is out of 180, that's going to be equal to, so that's not a sad face, that's an equal sign. Assuming 0 is the rightward direction, that would be 180 minus 26.56 or whatever. All right, so let's round your answer to the nearest degree, okay? So if we add 180 here, nearest degree 153.43, so that's just going to be 153. So got to make sure of your quadrant here, okay? All right, and this is just a diagram to help us understand things. So let's check our answer. Got it right. Let's move on to the next question. Clearing annotations. All right, teams A, B, and C are playing a game of strength. Test your might. Mortal Kombat. Each team has attached a rope to a metal ring and is trying to pull the ring in their own area. Team A pulls with force vector A, 5i plus 2j. Team B pulls with force vector B, -6i, 1j. And Team C pulls with the force vector such that the ring does not move. So if the ring is not moving, what that means is that Team C has completely countered the horizontal and vertical components of A and B. So that means vector A, horizontal component of 5, vertical component of 2, vector B, horizontal component of -6, vertical component of 1, vector C, we need to find this out, but we know that at the end of the day, nothing's moving. So our resultant vector, I'll just call that vector R to name it. It's going to have a vector of 0 and 0. So we need to figure out what vector C is. So 5 plus -6 is -1. And in order for our resultant vector to have a horizontal component of 0, this must be +1. Because 5 minus 6 plus 1 is 0. This must have a vector of -3, because 2 plus 1 is 3, minus 3 is 0. So these are the components for Team C. 1, -3. So let's find the magnitude. To find the magnitude is a simple process. So you can just find the magnitude of C. Let's find the, they have it in green here. Magnitude of vector C, that's just going to be equal to the square root of 1 squared plus -3 squared, which that's going to be equal to the square root of 1 squared is 1, plus negative 3 squared is 9. So 1 plus 9. That's equal to the square root of 10. So the mag is equal to the square root of 10. So find our value to the nearest tenth. The square root of 10 is equal to 3.16. So that should round up to 3.2. 3.2. And then what direction is team C pulling? Assuming 0 degrees is the right direction. Let's draw it out. We have here a horizontal component of positive 1 and a vertical component of negative 3. Right, so this is 1, this is negative 3, and our vector here is going to look like that. So we've already found our magnitude, which is about 3.2. But our direction is this angle right here. And to find this angle, we can find the inverse tangent. We can find the inverse tangent of theta. So theta is going to be equal to the inverse tangent of the opposite, which is going to be negative 3, over the adjacent, which is going to be 1. So we can find the inverse tangent of, in degree mode, negative 3 divided by 1, which is going to be negative 71.56 degrees. But it has to be an angle between 0 and 360. So instead of starting at 0 and subtracting 71 degrees, you could also add 360 to it to get your answer in quadrant 4. That's going to be 288.43. 288.43. So that's going to just stay at 288. So what we're doing here is, if this to also help you visualize it, 288 is quadrant 4. So if you really want to look at that 288, you can do 360 minus your calculator value, which is going to go down there. So 288 degrees, that's going to be like starting here and rotating all the way around that way. So you got to understand how angles work. Check it. Next question. Mighty Casey hit 2 baseballs out of the park. The path of the first baseball can be described by the displacement, distance and direction of vector b1. That's equal to 100i plus 10j. The path of the second baseball can be described as the displacement vector b2, 90i plus negative 20j. Values are given in meters. How much farther did the first ball travel than the second? And how far apart are the baseballs? So, Mighty Casey is starting at the exact same point. All right. And because he's starting at the exact same point, how much farther did the first ball travel from the second? We need to answer this question, we need to find first the magnitude of B1. So the magnitude of B1, which is how far the first ball is from home plate. Because just looking at the diagram, looking at how far the first ball is from home plate, it's it's the distance is just the magnitude of B1, and how far the second ball is from home plate is going to be that point from B2. So we just need to find, if we find the magnitude of B1 and B2, that's going to give us the distance from home plate right here. Make clear annotations and find the magnitude of B1 and B2. So the magnitude of B1 vector B1 is going to be equal to the square root of sum of the squared horizontal and vertical components. So it's going to be the square root of 100 squared plus 10 squared. And the magnitude of B2 is going to be equal to the square root of 90 squared plus negative 20 squared. So let's find out these values. We can take our calculator and find the square root of 100 squared plus 10 squared, which should be 100. Let me double check that. 100 squared is 1,000, and 10 squared is 100. So if you take the square root of 1,010, all right. What will actually do that'd be the square root of 1,000. 100 squared is 1,000 plus 10 squared is 100, so 1,100. All right, 33.166. I don't know. I'm supposed to probably plug it into the calculator wrong. So vector 1 has a magnitude of 33.166. $33.166. All right. And then B2 is going to be the square root of 90 squared. No, let me add another parenthesis here. The square root of 90 squared plus negative 20 squared, which should be all right, let's 90 squared is then negative 20 squared is 400, so that becomes 8,500. Take the square root of 8,500. 92.195. All right, and 100 squared is 10. All right, 10,000, and 10 squared is 100. That's taking the square root of 10,100 is 100.498 minus 92.195. So it's going to be 8.3. 8.3. So while I was having calculator issues there, if you can get it into your calculator, you can just find these values, which with your calculator, that's going to be 100.498 minus 92.195. 100.498, that's 92.195, and that's the magnitude of B1 and B2. How much farther did the first ball travel than the second? That's just going to be subtracting the difference, and in this case the difference would be 8.3. All right. And how far apart are the baseballs? Okay. So now you need to find the distance between these 2 points. Right, so you're going to have to find the distance between this point, and if you say you start at 0, 0, which will make things a lot easier, you will have, this point would have coordinates of 110, and this point would have coordinates of 90, negative 20. And so, how far apart are this would be 110. So to find the distance between the two baseballs, right, that's just this distance right here. What's the distance between 2 points, right? This is where we can use the distance formula. Right? Which is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So here the distance formula would be square root of 90 minus 100 squared plus negative 20 minus 10 squared. So that's going to be equal to the square root of negative 10 squared plus negative 30 squared. So the square root of 10 squared plus, find the square root of, and oh, it's fine, let's keep things technically correct. 10 squared plus negative 30 squared. That should be 31.622 meters. And just to double check that, find the square root of 10 squared plus 30 squared. 31.622. So 31.6. All right, let's see if we're right. Great. All right. Anjali's plane has been flying through calm skies, no wind, with a velocity, speed, direction vector v1 is equal to 400, 100. However, the air mass surrounding the plane is moving quickly, i.e., it's windy. Although Anjali has not adjusted any of the controls in the cockpit, the plane's new velocity is v2, 350, 50. So we need to find the speed of the wind. So this is the exact same process as an earlier problem. So the wind, right? So you have 400, 100. The final vector is 350, 50. So the wind is going to have a vector of negative 50, negative 50. So the wind is going to have a vector of negative 50, negative 50. So what's the speed of the wind? What is the square root of 50 using the Pythagorean theorem? 50 squared plus 50 squared. It's going to be 70.71. And what's the direction? So negative 50, negative 50. That means we are in quadrant 3. Negative 50, negative 50. So right, so our vector would be looking something like this. And our theta value would be right here. So remember, this is 180 degrees right here. To find our angle, we can find the inverse tangent of negative 50, the vertical component, divided by negative 50, the horizontal component. That's going to be equal to 45 degrees. That's great. But remember, we have 180 right here, and then to 180, we are adding our additional theta value. So in order to find our actual value in between, our answer should be between 0 and 2 pi. So it wants radians. Because of that, we have to go to mode, radian mode. All right. Mode, radian mode. Find the inverse tangent of negative 50 divided by negative 50. Right? And then, remember, that's 180 degrees or pi radians, right? So because of that, we're adding this value to all, we already have pi radians, so that's pi. Then we need to add our, find this total value. To find the total value from 0 degrees here, that's going to be equal to pi plus 0.785. To do that in the calculator, we can just add pi. So our answer should be 3.926. 2 decimal places. So 3.926 will round up to 3.93. All right, let's check our answer. All right, we're right. Okay, that's 100% in vector word problems. Hopefully that will show you how to do it.